Have you ever wondered why a concrete platform can remain stable on the sea surface, having a 50-meter-high mobile fortress, handling precise extraction, ensuring 18-meter waves withstand explosions from minus 44-degree temperatures during a magnitude 9 earthquake? Next, let's take a look at how a 200,000-ton drilling platform floats on the sea to extract oil. Looking back over the past 70 years, they were basically supported by foundations, not only being massive in size, but also very clumsy in structure, until a qualitative leap occurred in the 21st century. Abandoning the original design, they switched to a detachable modular construction, reaching depths of over 3,000 meters, no longer limited by terrain. From the outside, it looks like a solitary island, but inside, it has a cinema, a billiard room, and even an unexpected sauna, comas. As long as supplies are sufficient, it can easily accommodate the lives of 300 people. Now let's move on to the first step, making the tower body. Let's first lay the steel plates onto the base. To save space, each level is filled with dense pipelines and countless load-bearing structures. The final drilling rig will only be installed once all other assemblies are complete. At this point, the tower body takes on its specific shape, reaching an impressive height of over 6 stories. Next, it is prepared for transport to Sakhalin Island. In fact, this drilling platform is one of the world's largest single drilling units manufactured by South Korea for Russia. It can produce thousands of tons of oil in just one day, second only to the oil wells in the Gulf of Mexico and the North Sea. The massive 160,000-ton concrete structure is also cast and formed. Compared to the transportation of the tower body, the base seems more challenging. It often needs to be transported to the designated location 6 months in advance. Only after all the indicators and parameters are tested and qualified can the upper and lower parts be assembled together. The term assemble couldn't be more fitting. If you don't believe it, watch. As long as the 4 corners are aligned, it can be firmly compacted. The top is protruding and the bottom is concave, fitting snugly together. And the heavier the Moonchen drilling platform, the more stable it becomes. The principle is somewhat similar to the knee joint in the body. So how do you ensure that the oil well always stays in one position? Therefore, engineers have installed 4 anchor chains at the bottom. This makes it even more stable on the original foundation, and a hole has been cleverly excavated inside. When seawater is added to the appropriate position, no matter how big the waves are, they won't cause any damage. By comparing the images, you can see that the left side seems more stable. Each set is equipped with an independent cushioning device. When observed from a distance, it may appear fragile, but in reality, it can withstand a magnitude 9 earthquake and 18-meter-high waves. So, is it truly safe? With the cooperation of numerous protective devices, experts have not yet provided a 100% definitive answer, because based on past leaks, pressure could be triggered under various circumstances. Equipment aging and valve cracking are just some of the many causes. However, once crude oil is released, it is ultimately the result of a well leak. To minimize the damage, oil wells are usually equipped with 4 sets of escape pods inside, containing multiple sets of equipment such as water and flashlight signal emitters. Although they don't look large, they can accommodate 60 people. Yet there are 287 workers living there long term. So why aren't the escape pod positions determined by the number of people? Do you know the answer to this question? Inside the oil well, there are multiple sets of drill pipes with a total length exceeding 10,000 meters. They are connected to the strata several kilometers below, which are rich in oil and various types of natural gas. The natural gas reserves, in particular, are under high pressure and extremely dangerous. A small mistake can easily lead to a fire or a leak. Leaks occur to the extent that ordinary cans cannot meet the current requirements. The blade head is installed under the coal all day, even showing a bright appearance. In fact, compared to land-based mining platforms, the working environment is significantly better. You can sit and remotely control while drinking coffee. And even without touching the oil, you can produce thousands of tons daily. During the process of extending downwards, at a fixed point, the fuel stone and soil generated will be discharged along with the water pressure. Once the casing reaches a sufficient depth, the head will continue to probe downwards in place, while a smaller casing is inserted, followed by injecting concrete inside. At this point, you cannot stop. You must continue to apply pressure until the concrete completely fills the space outside the casing, forming a permanent structure. Only then can you insert the next smaller pipe and complete all the above steps. Once reaching the smaller size, the long-awaited blowout preventer is attached on top. The blowout preventer is used to control the entire spraying device of the water apparatus. If the oil pressure becomes too high, it can cause the oil well to burst. The chain reaction triggered by such high pressure is extremely dangerous. If the pressure-induced explosion is not controlled in time, it can lead to a devastating impact, as once the oil well bursts, it is very difficult to seal. Therefore, engineers have cleverly designed a type of throttling device. This structure is similar to a tap, and incorporates multiple throttling methods based on the original design. One group is on the other side, which is closed first, but it is not done all at once. Instead, it is done from bottom to top, closing only a small part each time. Only after the first 4 groups are completed can the topmost throttling method be sealed. This is done step by step. To put it simply, if all 5 throttling methods were closed at once, the oil pressure generated by the extraction would likely blow off the blowout preventer. This is not an exaggeration, as the water pressure at several thousand meters is beyond what humans can withstand. Not to mention that during the extraction process, an impact force is formed. If the flow is abruptly cut off, it can easily cause the pipeline to rupture. Now, let's see how the platform transports crude oil. Each oil rig is connected to the main pipeline below, and it is only through layer-by-layer transmission that the oil reaches the refinery. If you have a map of the crude oil pipeline distribution, you will find that the pipelines are closely connected to coastal areas. Moreover, fresh crude oil is not purely black, but is a yellow to brown, decomposed substance. Typically, the drilling platform also has a final protective device, which is the blowout preventer located within the oil field. Although it cannot extinguish fires, it can provide workers with more time to escape. Secondly, the electricity usage for over 200 people is a major issue, so the platform has multiple high-powered turbines to meet daily needs and provide some relaxation. However, with only $50,000 a month, how long can you stay here?